Hello everyone, still in the decision-making analysis about integer programming. This time we will learn about the second type of integer programming, which is mixed integer. Okay, let's see. Here you go. Mixed integer programming problem example. So if the case is mixed integer, this is the case. Buckwell Chemical Company. It is a company produced two industrial chemicals. The first one called as xylene. Xylene must be produced in 50-pound bags. And the second product is hexal. Hexal is sold by the pound and can be produced in any quantity. So the result must be in integer and the other one is in real. Which one is in integer? Yeah, xylene must be produced in 50-pound bags. So one bag consists of 50 pounds. This is just like a product that we often see in some department store, like rice in 5-kilogram packets, etc. So that's meant in just like xylene must be produced in 50-pound bags. So one package that we need to be concerned is about the bags. Bags inside the bags is 50 pounds of chemical. So for the xylene, the result must be in integer. And the second product, hexal, is sold by the pound and can be produced in any quantity. This is the keyword. Any quantity means you can produce it not in integer value. We can produce it 1.5 pound, etc. That means this is in real value. Because one result must be in integer and the other one can be in non-integer or in real or decimal. So this case is considered as the second type of integer programming. That is mixed integer programming. Now we need to create the equation or the modeling. So here, this is the both xylene and hexal are composed of 3 ingredients. 3 ingredients must be as the constraint. There are 2 important things that we need to create in integer programming. The first one is objective function. If we have the information. So objective function and also constraint function. The constraint can be derived from this point, but xylene and hexal are composed of 3 ingredients, A, B, and C. This must be come on ingredients of this case. And Buckwell sells xylene for $85 a bag. That's the keyword, bag, not 50 pounds, but bag for the whole bag integer. And hexal for 1.5 per pound, but we can produce it in any pound. So I think we got the clue of the objective. Xylene, sell xylene. The objective is want to sell. If we are talking about the selling, we want to see or find the most profit, the highest number of profit. So this case must be maximization of profit, the objective. So Buckwell sells xylene. We need to define silane and hexal first. So we create X for silane and we call Y for hexal. Okay. This is the objective function. The first one is objective function. The objective function is maximization. 85 x plus 1.5 y. This is the objective or profit function. Okay. Buckwell wants to maximize profit. So exactly, we got the maximum profit function or objective function. Yeah. 85x plus 1.5y. Let x number of 50 pound of silane and y is number of pound of hexal. This is the constraint ingredient A, B, and C. Amount for silane is 30. But before we create an this equation, let's see the last column. Amount of ingredient available. So availability is the keyword. That means 2000 for ingredient A means that is the maximum number available. So that's the highest number that we can use. So the constraint function, the first constraint function is about ingredient A. For ingredient A, is 30 silane plus 0.5 hexal because its availability or available, so it can be less than or equals to 2000. Okay. And constraint B is 18x plus 0.4y less than or equals to 800. And for the last constraint is 2x plus 0.1 0.1 y less than or equals to 200. This is a mixed integer. I told you before, because x must be in integer and y we can have non-integer or real value for y. Okay. After we're done with the equation, yeah, this is the total of the equation, complete equation, just the same with what we created in this tab 38.0. With the last constraint is non-negative, and with the value of x must be in integer, and that means the y can be in non-integer. Then let's solve it using QM. Open your QM. First thing to do is choose the module integer and new. We have the case is, what is the case? Yeah, mixed integer. Number of constraint 3, ingredient A, B, C. Number of variable 2, silane and hexal, X and Y. Okay. Hide this panel. The objective still the same, maximizing X1 become X and Y, and the constraint is ingredient A, ingredient B, and ingredient C. The maximize is 85 and 1.5. There you go. Right hand side. Okay. For ingredient A, constraint first constraint is 30 plus 0.5 equals to or less than 2000. 18 with 0.4 equals to 800. 0.4 just type as 0.4 because 0 in front of the number is not appear by this system. Okay, and don't forget to choose the mixed integer. X or silane must be in integer in 50 pound bag, but on the other hand, Y or hexal can be produced in any quantity, so this is real. After we've done with the equation, click solve, and we will see the result. For silane, it must be produced in 44 bags, and hexal is in 20 pound, with the maximum profit that can be achieved is $3,770. Iteration. You want to see another result? This is the simplest one. Ingredient A, and this is the solution. For X or silane is 44. Y for hexal is 20. With the profit is $3,770. This is the graph. It's so easy. Yeah, that's it for the second type of integer programming. I'll see you again in the next video tutorial about third type of integer programming, namely 0-1 or binary integer programming. So see you and stay safe.